Hello, my name is Michael and today I'm going to present about the quiz 5 of solid. So the first question is to determine the slope at A and the deflection at D. Here we know that there is a force at A in the Y component 15 kN, force at Y component in D 8 kN, and force at Y component 15 kN at B. And we also know that there is a pin joint in E and a roller component at C. And then we also know the beam cross section, which is B equals to 90 kilometer, and then the D will be changed from 170 to 278 millimeters. So first step is we have to identify the nodes. So the force in AY is 15 kilonewton, force of DY equals to 8 kilonewton, force of BY 15 kilonewton, and then the length of AC to CD to DE and to EB is the same, which is 0.3 meters, and B equals to 90 millimeter and D equals to 278 millimeters. So here to draw the FBD is simple. We just do the same and then put the external force. Here there should be a force in the X component, but since there are no contradicting X force, no other force in X, so there is no force of E in the X component, so there is only force in the Y component. Next is we have to determine the reaction force. So sigma M equals to 0, so 15 times 0.9, creating a counterclockwise movement, and minus Cy times 0.6, making a clockwise movement, plus 8 times 0.3 counterclockwise movement, and minus 15 times 0.3 clockwise movement. And then you add them together, you get 0.6y equals to 11.4, and then the Cy you will get 19 kN by dividing the 0.6 in both sides. So sigma Fy equals to 0 to find the Ey. So minus 15 plus 19 minus 8 plus Ey minus 15 equals to 0, and then the Ey will be 19 kN. Here to draw the SFD, it is quite simple. We just need to graph the FBD. So first there is a force of 15 kN, so we need to draw minus 15 from 0 to minus 15, and then it will stay there until it touches the C point, or the where there is the force of 19 kN, so it will go up. So minus 15 kN plus 19 kN is 4 kN, and then it will stay there the same until there's also another component 8 kN affecting it. So 4 kN minus 8 kN equals to minus 4 kN, and then again there is the force again 19 kN, so minus 4 plus 19 kN, which is 15 kN, and then lastly 15 kN minus 15 kN, which is equal to 0. And for the BMD, you just need to simply multiply the length of the every part with the SFD. So for the first part, we know that it is minus 15 times 3, which is 4.5, and then it will be minus 4 times 3, which is 1.2, and then plus by 4 kN times the length, which is 3, and then minus 15 kN times 3. So the BMD will be like this. So the maximum BMD is the 4.5 kN. And then next we use the superposition method. So we know at first that the first that the length ABCD and D to E is the same. So to make it simple, since they are symmetry to each other, the first and the left side and the right side, so we just need to divide them both and they will be like this. And then divided the force, so there is 15 kilonewton in the A component and then 15 and 19 kilonewton at the C component. And then after we draw the superposition method of the force, we need to draw the SFD of the force. So this so we know that there's the minus 15 kilonewton affecting the A. So the same, we draw the SFD and the BMD also. So the SFD first is from the A to C part, and the second part is 19 kilonewton is from C to D. And then this one is for the moment or the BMD. So for the moment diagram, it is like this. And then to determine the moment, we just need to multiply the SFD force, or it is minus 15 kilonewton, and then times the distance. So it will be from A to D, so times 0.6, which is equals to minus 9 kilonewton meter. And then for the CD, so the moment at CD equals to 19 kilonewton times 0.3, which is 5.7 kilonewton meter. Next, this is the step 7, which is to find the moment of area. For the moment of area, we need to combine the first part of the BMD of the superposition method and the second part of the BMD of the superposition method. So we combine them together into one graph. So here, as you can see, MAD, so this is the first part, and then the right part is the second part. Combine them together and we have two areas. The bottom one is the first part and the upper one is the second part. And then this is also notated with M divided by E times I. And then the next is we have to determine the inertia. So from the question, it is simple. We know that the inertia formula is I equals to 1 over 12 BD cube. So I equals to 1 over 12 times B, which is 90 millimeter, and if we change it to meter, it will be 0.09, and D, which is 278 millimeters, and if we change it to meter, it will be 0.278. So the I we will get is 0.16 meter cube. So for the step 9, we need to find the area of A1 and A2. So A1 equals to M1x over 2EI, which is equals to 1 over 2E multiplied by the I, which is 0.16, and times M1, which is 5.7, times X, which is the length, is 0.3. So A1 is 5.34375 divided by E, kilonewton meter square. And for area 2, the same thing. Multiply the M2 with X and then divide it by the 2EI. So it will be 1 over 2E times the I, which is 0.16, times the M2, which is minus 9, and the X, or the length, is 0.6. So the A2 will be minus 16.875 divided by E, kilonewton meter square. So we need to find the step 10 is to find the slope using the first moment area theorem. And then since beam AD is symmetric to the beam DB, so we put D as the reference tangent because it's a symmetric point. So the slope D will be equals to 0. So The first moment area theorem is the slope d over a equals to slope d minus slope a. And then since slope d is equals to 0, so we substitute it. So slope d over a equals to 0 minus slope a. And then this slope a equals to minus slope d over a. And then slope e equals to the minus moment from a to c, which is minus the e divided by the total area, or a1 plus a2. So if we substitute a1 plus a2, we will get slope a equals to e over minus e over 5.34375 plus 16.875 equals to minus e over 11.5. Then for the finding the deflection, we find the deflection using the second moment area theorem, which is yd equals to td over a minus td over c. So yd equals to, we change td equals to a times the c, which is the middle point of the length. So area 2 times c minus area 1 times c. So this c is the middle point of the length. So since this is a rectangular figure, the middle point will be a third of its length. So yd equals to a2 times 0.6 divided by 3 minus a1 times 0.3 divided by 3. So the yd equals to 5.34375 divided by e times 0.2 minus 16.875 divided by e times 0.1. So it will be 2.75625 divided by e.